So a while back, a YouTube viewer of mine sent me this transmitter design via email, and he watched some of my older transmitter videos and whipped up this design himself. And as you can see, it looks like it was designed by somebody who actually knows what they're doing, because it's got all the resistors, the capacitors, all the passive components with the correct values, all calculated, stuff I haven't figured out how to do yet. And it's got a variety of transistors here too, not just 2N2222s. So let's go over some of the parts of this circuit before I show you what I built. So coming in here, we have the audio line, and the audio line goes into this 2N3904, you know, the 2N2222's less popular brother. And this is the audio amplification circuit. Specifically, this is a Class A audio amplifier. And this already solves one of the problems with my previous designs, that the audio was always really quiet on the receiver, and I'd have to crank the volume all the way up because it was never amplified. But this solves that problem. Now down here we have a Pierce oscillator, and this is similar to the type of oscillator that I always use in my transmitter designs, but it's a bit different. This uses a N-channel JFET. That's an N-channel junction field effect transistor, specifically a 2N4117, which I ordered especially for this design. And the reason for using this N-channel JFET rather than the usual BJT transistor is because, according to the creator, it provides a much more frequency stable output, which is very good. And then up here we have, it can use two different types of transistors. I chose the BF494, it's an NPN transistor of course, and this is the modulator. It takes the audio signal and the carrier and slams them together and makes amplitude modulation. And as you can see, it's got all the different parts around it, resistors and everything. And right here between these two components there's a potentiometer, so you can control the volume that ends up getting into your transmission. And as you can see right here, there's no filtering, no amplification. The output is derived directly from the transistor, and in keeping with this design, I'll keep it this way. But in future iterations, which I will make some, I'll amplify and filter, perhaps even impedance match and make it ready for ham radio. But for the time being, this is the circuit. And so this is what I spent the last 2 weekends working on. Well, actually the first weekend I worked on prototyping it on this, ironing out some of the issues, and then I built it this weekend. And so this is what we have. It's very compact. I've gotten good at my soldering since my original videos, and I can squish everything together pretty nice with some very high profile soldering. But anyway, this is it. And so we get power input, runs on 5 to 12 volts, ideally, and I run it off 9 volt as I usually do. Here we have the potentiometer, a 3.579545 crystal. I'll say a bit more on that later. And then the antenna output, and this left one here is the antenna. Right one is a ground in case you have coax or something that's shielded that needs ground. And there's a little indicator LED to show you when it's on. Now this thing looks pretty nice, but there are problems, which is why I'm calling this a prototype. So the first issue was this oscillator design right here. Now I like this design, and I think there's absolutely nothing wrong with it. But for some reason, when I prototype it and build it, it doesn't work. Now, yes, I have made sure that all of the surrounding components are correct, and I measured them, I've tested them. All of that's fine. But I'm thinking the only reasonable explanation, see here's the N-channel JFETs I ordered. There's a third one, I forget where it is. Could be that they all don't work. Now, that would be kind of unlikely, but I don't know. That's the best solution I could come up with. I've tried building it, both with the circuit and standalone, because it should be able to work on its own and just output a signal, and it just doesn't. Now these transistors, you can see they're that CAN type with the 4 pins. I believe this is called a TO-72 form factor, as opposed to the TO-92, which is the standard one, and then the black casing with the one flat side. And these things are kind of annoying, because they've got the 4th pin, which is actually shorted to the housing, for ground purposes, I guess. But yeah, I have hooked them up correctly, but I don't know what the deal is. And so, since this is a prototype, in an act of getting this to work, I've gone with my usual design here, the one that I've been using for years, simple one that's so easy I've memorized it. And of course, ideally I would have liked to have used this, but I stuck this in here just to get it working. And it works just as it would normally. Perhaps it's less frequency stable, but I'll revisit this in the future. The other problem is this audio amplifier, and here I'll give you a demonstration on my oscilloscope. So I'm going to show you the audio line. So first, this is directly out of the iPod's headphone jack without amplification or anything. This is coming straight out of the iPod. And it looks like an audio signal, pretty good. Although it's a bit quiet right now. Hold on, let me switch to a different piece of music. I don't know what's playing right now, but that's not really important. There we go. So that's what it looks like. Now this is after it's gone through the capacitor, the little DC isolation capacitor. You can see it's a little bit de-amplified. And actually this isn't as bad as what I was seeing before, but it's not making very good contact. There we go. So already the capacitor seems to be de-amplifying. It gets worse. Here is the output on the transistor. Well, it's certainly louder, but look at that. It's not really very AC looking like. It looks pretty flat with a bunch of spikes going straight up and down. And this is audio distortion at its finest. Now, I don't know why the transistor is distorting the audio. And again, I've spent the last weekend testing this particular part of it, trying to get it to work. I found if I remove the transistor and just pass the unamplified audio directly to the modulator, it comes out fine, but at the cost of it being a lot quieter. But of course that also shows that the capacitor acts normal when the transistor isn't there. So I don't know, any suggestions would be nice. But sure enough, if I tune the radio up, yeah, the audio sounds pretty distorted. Right now we're supposed to be listening to a polka, but it just sounds like a bunch of noise. Although if you listen to it, you can kind of pick out the instruments. So anyway, that's those problems, and there is one more problem, and I don't think it's with the design. I think it was with my putting together of the circuit. You see, well, the design calls for a 7.2 megahertz crystal, and that's because it falls into the 80 meter amateur radio band. But since this is kind of a prototype, a test, I don't really care what frequency it's on. And so I stuck in one of my regular 3.579545 megahertz crystals, because I have a lot of them and it's pretty good frequency. And I suppose it's not too crazy far off from the original, and I don't think this oscillator and this circuit is very frequency dependent. So as long as I don't add 100 megahertz or something crazy like that, it shouldn't be a big deal. But for some reason, instead of getting 3.579545 megahertz transmission, it's on 10.563 megahertz. Now I know that there are some methods you could do with a crystal to drift it up or down a few kilohertz by adding some extra capacitance, but this is like an increase of 7 megahertz. Now my best guess is that because I stitched everything so tightly together here, there might be some interference and crosstalk between the three major components of the board. And so what I probably could do in the future is maybe separate them out a bit. And if you look in RF modulators, you'll notice they'll kind of enclose them in metal, but then also have different metal walls and things like that. So I might implement that a little bit, but for the time being, it's a 10.563 transmitter. Well, other than those three issues, the thing works. And besides this having to be different, I built everything up here more or less exactly the same. And the creator claims here up to 70 yards with a 3-foot piece of wire as an antenna, 22 gauge or equivalent. Now this thing is already kind of compromised for reasons unknown, so I have a feeling I'm not going to be getting 7/10 of a football field, but I would like to see how well this works. Of course, it was recommended to me by the creator that I stick it in a metal housing. So I got this little mint tin here that I've stuck it in. As for the antenna, instead of 3 foot, since it was convenient and I want better performance, I've strung some alligator clips together going up here, and I measured this about 6 foot. 6 and some change. So let's see what happens. Well, I'm standing in the bathroom on the other side of the house, and this thing is still holding up. It's a little cut out right now, but that's just due to the audio and the music right now, but it is making it through pretty clearly. Well, now here I am now, and I'm still faintly hearing it. This is actually quite a bit of a distance. Well, there we have it. And for the official number, based on where I was standing, where I heard it the furthest, I went and plugged that into Google Earth, and for the official number, I'll say about 40 yards is the best I got, which is pretty dang good. It's not 70 yards, but of course there are obstructions and interference, and already the radio is not all that good. I think the problem is that, well, despite the audio distortion, it is getting out pretty far, but because the audio is distorted, it's kind of hard to hear the signal, especially when it gets to quieter parts of the music, which is especially annoying because then I have to go run in and change the iPod over to play something else. But I'm going to say 40 yards, which is pretty good. And if I got the audio distortion sorted out, I mean, this would be a near perfect transmitter. And then I could amplify and filter, and then I'd be good. Well, anyway, here's my plan for this transmitter. Now, I've been referring to this as a prototype, and that's because when I built this, I had to make some compromises due to parts I didn't have or parts that didn't work. And there are some issues or inconsistencies with it, and that's fine. So I'm going to call this the prototype. In a future video, I'm going to fully rebuild this one-to-one, exactly everything. I'll try to get some new N-channel JFETs. I'll try to sort out the audio amplifier, and I will test it and see how good the full-blown circuit works. This is pretty close to the circuit, but it's a little off. Plus, I'll also try separating some of the components on here, spreading them out, and shielding things a bit better. And hopefully that can eliminate the frequency drifting, among other issues. And so this I'm going to call the P0. I'll give them numbers just to keep track of them. That next one is going to be the P1. And then the P2, which will be the third stage in this 3-stage process, will be a ham radio enabled version. The creator and I have kind of talked back and forth, and we've talked about putting some amplification, filtering, impedance matching, various things with this to make it good for 40 meters, which is why this was originally designed for 7.2 megahertz. And I have a 7.159 megahertz crystal, which will work fine. And so yeah, that is how this is right now. I wish it didn't come out so half-baked, but this thing has been on my to-do list since May, and I've kind of, unfortunately, due to being busy and school started up again, I've kind of been kicking the can down the road, so I wanted to make a video. And here it is. Despite the audio amplification issues, already this is proving to be a very good circuit, much better than mine. Anyway, that's going to be it for this video, so I hope you enjoyed, and I'll see you in the next one.